Now, the case of our own natural history, the history of humans, is one of the cases where paleontologists and especially Darwinian paleontologists will say, well, this is also a case where we have a transitional series from ape-like creatures to modern humans. But there are several problems for Darwinism also in the question of the origin of the human species. One problem is that it is not true that there is a gradual transition between ape-like Australopithecine forms and the genus Homo. Actually, the genus Homo originates very abruptly. First, you have small-brained forms which are very ape-like in their skull and which have a relatively primitive pelvis. Maybe they were bipedal, but they were clumsy in their bipedal gait. And then you have completely bipedal hominids which were able to run like a modern human, which have a big brain, and which have a modern human skull. And this has sometimes been called even the Big Bang of the genus Homo, so which shows that is an expression that didn't come from Darwin doubters, but from Darwinian scientists themselves. So that is one of the problems. The other problem is also that this typical textbook scenario, this out of Africa story that humanity originated in the eastern part of Africa, and that they then once migrated out of Africa and spread all over the world, and then there was a population bottleneck caused by the so-called Toba volcano eruption in Indonesia. You find this scenario everywhere in the textbook, and in the past 2 or 3 years there was really every month one discovery after the other which has shown that this scenario is no longer tenable, and it has basically been refuted. Of course, you can say, well, that's just the progress of science, and we were wrong before, and now we know more, and this changed. But it shows that you have to be a little bit careful if you look at the textbook and people tell you, well, that is fact, evolution is a fact. The fact of today is the error of tomorrow. So it's always good to be a bit cautious and to question the evidence. But more importantly, also in the case of humans, you have a waiting time problem. And we know from the fossil record that we have just about 6 million years available for the split since the splitting of the chimp lineage from the human lineage. And then people say, but they are so similar genetically. We have the genome of the chimp and the humans. They just differ by 2 to 5%. This sounds striking at first, but then you have to imagine that every percent of difference means 3 million base pairs of difference in the genome. So 2 to 5% difference means many millions of genetic differences. And these differences have to originate in the population, and they have to become fixed in the population. You have just 6 million years available. And there has recently been a paper by John Sanford and his colleagues who studied this waiting time problem for a supposed ancestral human population. They assumed a population like mainstream evolutionary biologists of about 10,000 specimens. That would be a kind of bottleneck population, as it is postulated by mainstream evolutionists. They took a generation turnover time of about 25 years, which is typical for large primates and humans. And they did the math, and what they found is that even for point mutations, not coordinated mutations, but to get the point mutation fixed in the population, they had times between 1.5 and 16 million years. And for coordinated mutation, if you assume just a single one, they had more than 80 million years. But you have only 6 million years available. So there's, again, a waiting time problem also in the case of human evolution. So human evolution is also far from being a poster child for evidence for Darwinian evolution, if you look more closely.